So now we want to talk about inequalities involving the absolute value function. So just as a reminder of what the absolute value function does, first of all, the absolute value function is represented by two bars, right? Two vertical bars. So what it does is it outputs the positive version of whatever number is inside of the brackets here, the bars. So the absolute value of -2, we would say, is 2, positive 2. Similarly, the absolute value of 2 is just going to be 2. So sometimes we like to think about the absolute value as like the distance from 0. So in that sense, -2 and 2 are both 2 spots away from 0, right? If we think about it on a number line, right? We have 0, 1, 2, -1, -2. Okay, and that's a perfectly fine way to think about it. Actually, just, real quick, if we think about, if we have the distance formula that we made in one of the early videos, if we think about doing that for one dimension, what it looks like is taking the square root of one of the coordinates, so in this case -2, minus the other coordinate 0. So thinking of distance from 0, we're going to subtract them and square it, and then take the square root. Well, the square root and the squared, they kind of cancel each other out, and what we're left with is the absolute value of -2. Okay. So the reason that we write this as the absolute value is because we're only looking at the positive square root, the principal square root, we call it. So whatever is inside there should be positive. So we would write this as the absolute value. So this is kind of why we think about it as the distance from 0. So there was a little bit of a sidetrack there, but just kind of showing where it comes from. So hopefully that makes a little more sense. So anyway, getting to the inequality part of this. Okay, so we want to think about, what does it mean if we have the absolute value of x is less than 2? Okay. Well, first of all, let's just think about what it means for the absolute value of x to be equal to 2. We didn't really look at absolute value equations too much, so let's just think about this for a second. So in an equation sense, this means that if the absolute value of x is 2, well, we just saw two numbers that satisfy this, right? -2 and 2. So x could be 2, or x is -2. Okay. So we get two different solutions for this. And sometimes when we're solving absolute value equations, like a more complicated equation, we might break it up into two cases like this. So if we have 2x plus 4 is the absolute value of 2x plus 4 is equal to, I don't know, say 3, we might break it up into two cases and say, okay, the absolute, or 2x plus 4 is equal to 3, or 2x plus 4 could be -3, right? Because we know whatever's inside that absolute value, it has to be either 3 or -3, so that when we take the absolute value of it, we get out 3. Okay, so this is kind of the strategy, and we're going to use the same strategy for inequalities. So if we just go ahead and do this one real quick, we have 2x equals -1, x equals -1/2, 2x equals -7, x equals -7/2. So if we go ahead and apply this logic to inequalities, then let's just first think about, what does it mean if we say absolute value of x is less than 2? So this means if we just think about what the numbers that would satisfy this would be, right? 1, of course, would work. The absolute value of 1 is 1, which is less than 2. 0 would work. -1 would work, right? Because the absolute value of -1 is 1, which is less than 2. But then like -2 wouldn't work because the absolute value of -2 is 2, and 2 is not less than 2. If we think about this on a number line again, then, okay. Then if we just think about, okay, 2 doesn't work because 2 is not less than 2. But then all the numbers on this point works on this line here until we get to -2. Then it doesn't work anymore, as we just noted. And then once we go past these points, nothing works either. Okay. So what we can see is that this is the same thing as saying that x has to be less than 2 and greater than -2. So in other words, we must have x is less than 2 and greater than -2. Okay. So x has to be any number between -2 and 2. If we want to write with interval notation, it would be like this. So here's 3 different ways that we could write it. You can also write it with the number line. So the absolute value is kind of used a lot in this situation because it's kind of shorthand for the and inequalities, as we can say, assuming that it's with one number. So like the absolute value of x being less than any number k implies that -k is less than x is less than k, right? And if you want to throw a less than or equal to in there, you just put some less than or equal to's in the other inequality. Okay. So this is assuming k is positive also. Okay. Sometimes you might get a question where it's just kind of trying to trip you up, where it might say, okay, solve the absolute value of x squared plus 5x minus 7 is less than or equal to -10. Okay. And you might look at this and you go, well, I have no idea what to do. And it doesn't really matter that you have no idea what to do because this can't possibly have a solution, right? And just think about what this is asking you. This is saying, when is the absolute value of something less than or equal to -10? Well, it can't be, right? The absolute value function has to be positive. The lowest number it can possibly be is 0. So we just would know automatically this is no solution. Okay, so it can't be less than or equal to a negative number. Similarly with equations, maybe sometimes you get a problem that says, to solve that this is equal to -10, and same thing, you would say, well, no solution because absolute values can't output negative numbers, right? If we just think about what the graph of the absolute value function looks like, it looks like this, right? There's no negative outputs for this function. Okay, so it can't ever equal -10. It doesn't have a y value down here. Now, if we flip the inequality around, let's say, okay, what about when x is greater than or equal to 2? The absolute value of x is greater than or equal to 2. Well, this is basically the opposite inequality of this. So we should have every other number on the chart here, right? So basically -infinity to -2 including -2, and then 2 to infinity, including 2. And that's exactly what it would be if we think about this. Okay, like 2 itself would definitely work, 3 would work, 4 would work, etc. And then -2 would work, -3 would work, -4 would work, because we take the absolute value of those and we get the positive counterparts. So we'd have 0, 1, 2, 3, -1, -2, -3. And we'd say, okay, it's 2 to infinity and -2 to -infinity, right? So writing that in interval notation, we have -infinity to -2, union 2 to infinity. Okay. And in other words, this is like our OR inequalities, right? X is less than or equal to -2. or x is greater than or equal to 2. Okay. So in general, this will be true. The absolute value of x is greater than some number k is equivalent to this symbol right here, an equals sign with like arrows on the end, means it's equivalent to x is less than negative k or x is greater than k. Assuming k is positive again. Why do we need that assumption though? Well, if k is negative in this case, if we have the absolute value of x is greater than negative 2, well, that's always true, right? Because the absolute value of x is always going to be a positive number. So in this case, any number works. So this would be just negative infinity to infinity. Okay. So we've got to be really careful when we have negative numbers on the opposite sides of absolute values, whether it's in an inequality or in any equality. Okay. So let's do a few equation examples now. So how would we solve x minus 1 is less than or equal to 3? Well, we would say, okay, we'd break it up into two cases, just like we would for an and inequality, right? We'd say, okay, x minus 1 is less than or equal to 3, or x minus 1 is greater than or equal to negative 3. Okay, or I guess we should say and. Okay. So if we solve this left one, we'll add 1 to both sides. So we have x is less than or equal to 4. If we solve the right one, we have x is greater than or equal to negative 2. So we go ahead and combine those, and then we can get, maybe we'll just write it with the inequality sign. So negative 2 is less than or equal to x is less than or equal to 4. All right, now let's do negative 2 times the absolute value of k minus 4 is less than or equal to negative 6. Okay. So here whenever we don't have the absolute value just completely by itself, we want to kind of get rid of everything else to make sure it is by itself. So we want to divide both sides by negative 2, because then we'll know how exactly to approach the inequality. So these will cancel. We'll be left with k minus 4 is greater than or equal to 3 because of the dividing by the negative. Okay. So this means that k minus 4 is greater than or equal to 3, or k minus 4 is less than or equal to negative 3. Okay. So we have k is greater than or equal to 7, or k is less than or equal to 1, looks like. And so that would be our answer. Okay. Now let's do a bit of a trickier one here. Let's say we have negative 1/2 4x minus 5 in the absolute value plus 3 is less than 0. Okay. So we need to subtract 3 first. Like I said, we should get the absolute value by itself first. Okay, so that'll leave us with this. So we have negative 1/2 times the absolute value 4x minus 5 is less than negative 3. multiply both sides by -2 to get rid of the -1/2. So we have 4x minus 5 is greater than -6 because of the sign flip. Oops, so this should have been -2, so this should be +6. Right. So now, and now it's pretty much the same as the one we just did. So we just had one extra step there. So 4x minus 5 is greater than 6, or 4x minus 5 is less than -6. So we get 4x is greater than 11, x is greater than 11/4, or 4x is less than -1, x is less than -1/4. Okay, so I want to do one more here where there is a variable on both sides, because this can change it a little bit. So let's say we have the absolute value of 3x minus 4 is less than, well, let's just say 3x. Okay. So we have two cases here, right? We have 3x minus 4 is less than 3x, and 3x minus 4 is greater than -3x. Okay. And actually, I want to do +4 here, now that I'm thinking about it, because this will make it a more interesting problem.